Okay, so we're looking at lab 1, question 1. This is an inclined plane and we have a mass here. The mass is 100 kilogram. So here we have our y component and our x component here. Now the x component is mg sine theta and the y component is mg cos theta. Now here we have our horizontal, which is f cos theta. Now from the y component, it is perpendicular to the normal. Once you talk about the normal, it is 90 degrees. So here we have 60 degrees and then 30 degrees. 60 plus 30 degrees, it gives us 90 degrees. And the same thing is happening over this side. Okay? Now, using Newton's second law of motion, the sum of F is equal to 0, which is the sum of the net forces. Now, the normal force is the force the ramp exerts on the crate. Now, in this situation, the speed is constant. And once the speed is constant, the acceleration is 0 meters per second squared. Now, the question asks, what are the magnitude of F? All right? So, using Newton's second law, you have the sum of F is equal to ma, and the sum of F is equal to 0 because the acceleration is equal to 0 meters per second squared. And of course, ma is equal to 0. Now, this is the formula for acceleration. A equals v minus u over t, where v is velocity and u is initial velocity. V is actually the final velocity. So A is equal to 0 over t. Now we're going to let down the inclined plane be positive. So we're going to be moving in the positive direction. Now mg sine theta minus f cos theta is equal to 0. If we are trying to get the magnitude of f. So we have negative f cos theta equal mg sine theta. F cos theta is equal to mg sine theta. Now f minus mg sine theta divided by cos theta, we can write that a different way. Sine theta over cos theta is the same thing as tan theta. Now, here we have f equal minus mg tan theta, where m is equal to 100 kilogram and g is equal to 10 newton per kilogram. Multiplying both of them out, we get 1000 newton. And here we substitute it here with our negative value. I'll be explaining why we have a negative value here. And we multiply it by the tan of 30, which is 0.580, which gives us minus 580. Now the reason why we have minus is because in the question it says the force is pulling it up the inclined plane, and we choose down as a positive. So that accounts for the negative value. All right. Now we're going to be finding the force on the crate from the ramp. And of course, we are going to be using Newton's second law, right? And here again, the sum of the net forces is equal to 0. We're trying to get the normal force. So we have n minus mg cos theta minus s sine theta equals 0. And we have n equal mg cos 30 degrees. Substituting the 30, where you have theta plus f sine 30 degrees. N equal 1000 newton times 0.87, which is when you cos the 30, plus 580 times 0.5. The 0.5 is when you sine 30. So n is equal to 870 plus 290. And the final is n equal minus 1160 newton. The minus again is because down was chosen to be positive, into negative value for n.